Okay, we want to show that this is equal to I cot theta on 2. So let's start off with the messier left-hand side. Now, first thing I see is that we've got two complex numbers added, and they've got the same modulus, okay? So first thing I'm going to do is I'm going to put these both in exponential form. So the complex number 1 is e to the I0. So I'm going to change my 1s to e to the I0. And then I'm going to average 0 and theta, which will be theta on 2, which tells me I'm going to factor out an e to the I theta on 2. Remember, that's the trick that we do to add these. So e to the negative I theta on 2 plus e to the I theta on 2. For the bottom, e to the I theta on 2, that'll be e to the negative I theta on 2 minus e to the I theta on 2. Okay, and now what I'm going to do is I'm going to use the result that if you've got e to the ix plus e to the negative ix, that's equal to 2 cos x. Okay, complex number plus its conjugate is twice the real part. And also e to the ix minus e to the negative ix is equal to 2i sine x. Now the denominator looks almost like this with x equals theta on 2, except I don't like where the negative is. So what I'm going to do is I'm going to cancel this and this. That can cancel. I'm going to change the top to 2 cos x. I'm just going to pull out a negative on the bottom there. So it's e to the I theta on 2 minus e to the negative I theta on 2. So now that's going to be 2 cos x over negative 2i sine x. And we wanted to get a cot, so I can see, oh, I've changed them to x's. That should be theta on 2, apologies. So theta on 2, theta on 2. Okay, so 2's will cancel. I'm very close now. I just need to get an I there. So I can times top and bottom by I. Yep, so I'll have I. Cos on sine is cot theta on 2. And then I've got to over negative I squared, and negative I squared is just 1. So that equals to I cot theta on 2, which equals to the right hand side. Okay. So that's the first part done. Hence, so I'm going to have to use part A. Show that the solutions to that guy there equals -1 are, and then they've got 4 answers there involving cot, which has probably got something to do with part A. Okay, having a look at this, this is interesting. If you were to let A be z minus 1 on z plus 1, I've just picked A to be a random thing, then this equation is the same as a to the power of 4 equals -1. So that's the 4th roots of -1. So I can solve for A, and then I can sub back in and solve for Z later. So that's what I'm going to do. So R to the 4, e to the I4 theta. Now -1 is over here with a modulus of 1 and an argument of pi. Okay, and then because we're finding roots, we put a plus 2k pi, where k is an integer. You must write where k is an integer. So R to the power of 4 is 1, so R is 1. 4 theta is equal to pi plus 2k pi. So theta is equal to pi plus 2k pi on 4. Let's get those answers between minus pi and pi. Okay, so let's start off. We'll go k is 0. It's power of 4, so plus minus 1. 2 will get me beyond pi, but -2 will be between minus pi and pi. So I'm going to get answers of pi on 4, 3 pi on 4, negative 1 would be minus pi on 4, and negative 2 would be negative 3 pi on 4. Okay, so I've got answers for A. Okay, so I know that A is equal to e to the I theta. For those 4 values of theta, I'll keep them handy. I now want to manipulate and solve for Z. I'm actually going to leave it just e to the I theta rather than writing out the 4 solutions at the moment, just to save some space. So Z minus 1 on Z plus 1, that's what A was, is equal to e to the I theta. Let's solve for Z. Okay, so Z e to the I theta plus e to the I theta. This is me expanding. Let's bring the Z's on one side. Now, something interesting. This is going to look very much like your answer to part A, I can see already. Okay, so I'm going to drag the Z's on the left. So 1 plus e to the I theta there. Factor out the Z and divide. And hey presto, that is precisely what we had from part A. 1 plus e to the I theta, 1 minus e to the I theta. So this equals to I cot theta on 2 from part A. Okay, so now I'm going to sub in my values for theta. Okay, my pi on 4, my minus pi on 4, my 3 pi on 4, and my negative 3 pi on 4. So I'll get Z equals to I cot, and we're halving those. So plus minus pi on 8, and also I cot plus minus 3 pi on 8. Now that's almost the way that the answer is written. They've just dragged the negative out. So they'll be using the fact that just like tan, cot is also odd. Okay, so cot negative theta is equal to minus cot theta. So therefore Z will equal to, if we drag out the negative there using this result, we'll have plus minus I cot pi on 8 and plus minus I cot 3 pi on 8 as required. Okay, I'll see you in the next video.